This is the wearable GPS accuracy testing. I am Dylan Richard.
Hello, my name is Ian Van Ham, and I am with the Wearable GPS Accuracy Testing Group.
The main question the group is asking itself is how the watches compare to each other. So this is through the way they handle different maneuvers, and which can affect their accuracy and performance for athletes and consumers alike. So the idea of you get what you pay for is put to the test to find out how much of a drop in quality is taken when you save a few dollars at checkout. The parameters being compared to one another are the error in distance measured and the price of each watch. With this data from the tests, the group can find a rough estimate of how much error per dollar is taken in when purchasing a new watch. This is also dependent on what brand and what level of watch is purchased in terms of the quality of software.
So as we were looking at the prices of each watch, we tried to look at the features that the watch had as well, and the system of GPS as well as other features it might have. And we found that a lot of the watches have connectivity to phones or Bluetooth or the ability to play music, and that was a big contributor to the price. But it also, all the expensive watches had a higher quality GPS system and more software than the lower priced ones.
Hi, my name is Ian Van Ham, and I'm with the Wearable GPS Accuracy Group. This is our testing slide, and we did our testing on April 11th. We set up 3 test tracks that we were going to walk. We set up an oval test track, we set up a zigzag test track, and then we set up a straight line test track. And we flagged every 5 meters initially to mark it out so that we were able to repeat our tests accurately for each track 3 times. And we went down to Baghdad Field to do this, and it was a cloudless day, which is important because clouds in the atmosphere will slow down the GPS signal as it comes from the satellite to the watch, and that will just add error into the system. And on the right here, you see a picture that we took. This is our test subject, Quinn, and he has 6 watches on, so we had one person carrying all the watches to minimize that error. Hi, I'm still Ian, and this is our maps for our test track. On the left, you have the oval that we did. In the middle, you have the straight line track that we did on the road. And then on the right, you have the zigzag that we walked.
The 3 graphs on this slide are a culmination of all the data acquired during the test day. This answers the key question of what are you really getting for that price tag of the watch? The graph on the top right shows the average distance percent error for the oval track on Baghdad Field. The graph on the bottom right shows the average distance percent error for the zigzag track, which is also on Baghdad Field. Last but not least, the graph on the bottom left depicts the average percent error in distance for the straight line track on the adjacent road. It's easy to see some of the watches stay true to distance rather well, and most of them form a bit of a pack in the bottom. The interesting thing that the group would like to point out is the fact that the Garmin Forerunner 35, which is shown by the teal line, is consistently off by a rather large margin. This gave the group good outliers for some interesting data.
Hi, I'm May with the Wearable GPS Accuracy Group. What we expected for our data was the more expensive the watch got, the better the GPS accuracy would be because they're able to put faster and better processors in the watches. As you can see on the chart shown, this is what happened. The average error goes up as the cost goes down. Something we didn't expect is the older watch actually wandered really far in distance. We would be at like 40 feet and it would be way behind or way ahead depending on what track we were walking. Every watch that we used overestimated the data, so that was something we also didn't expect.
Hi, I'm Quinn with the Wearable GPS Accuracy Group. To conclude, we have found that in terms of GPS performance, you do get what you pay for. The more you spend, the more accurate the watch will be. One thing to keep in mind is this test only looks at open field performance with minimal interference from trees and buildings. Further research and testing would need to be done to continue to support our current findings. So what does this mean for someone wanting to buy a watch? Well, there are plenty of good options, with manufacturers also selling higher price and lower price watches than what was on our test. You will need to decide how important GPS accuracy is to you compared to other features, battery life, fit, and finish. For example, the Apple Watch, it performed excellent, it is feature-packed, it's essentially a smartphone, but it lacks in the battery life and potentially the robustness, as primarily the front of it is glass. The Garmin Instinct performed very well, has an excellent battery life of almost a month, specific tracking modes that are tuned to activities, and while it does have smartphone connectivity, it's not to the extent of the Apple Watch. The Instinct is also offered in a non-solar version that drops its price to $350. Performance of the GPS should remain exactly the same, yielding more bang for your buck. Basically, features heavily dictate pricing on these watches, and you do get what you pay for. But based upon our data, there's still a direct correlation between GPS performance and cost. As with every increase in price, we did see an increase in performance.